Namaste, this is Praveen Kajri here. Welcome to the video classes on IUPAC nomenclature. In the first part of the IUPAC nomenclature, I have discussed three main rules to write the IUPAC name. In the second part, I have discussed 5 sub-rules, and in the third part, I have discussed only 3 sub-rules. So in this class, let us discuss some more sub-rules. So in order to understand next sub-rule, let us take an example. So this is the molecule. So first main rule is identify the longest carbon chain. Identify the longest carbon chain. So just observe this. This is 1, 2, 3, 4, 5, 6. This is one longest carbon chain. One more longest carbon chain is here. So just observe this molecule. Same molecule I have written here. So this is also can be a longest carbon chain. Right, there are 2 possible longest carbon chain in this molecule. One is this one, 1, 2, 3, 4, 5, 6 carbons in the longest carbon chain. So in this case, 1, 2, 3, 4, 5, 6. So which longest carbon chain I have to select in order to write the IUPAC name for this molecule. So if I select this one, the name will be different. The name will be 1, 2, 3 isopropyl hexane. Isopropyl, this is the prefix isopropyl group, then 6 carbons, right, hex, carbon to carbon single bond, ANA. This will be the name of this molecule. If I select this carbon chain, this longest carbon chain, then what will be the name for this? So let us number the molecule 1, 2, 3, 4, 5, 6, right. So 3 ethyl, 2 methyl, this is the prefix, root word is hex, ANE is the primary suffix. So this will be the name. So which name is correct now? So this is the problem. For that the rule is sub-rule 9. If there are more than one longest carbon chains in the given molecule, then so which one I have to select? Then which one I have to select? The rule is then select the longest carbon chain which has more number of substituents. This is the rule. Right, if I select this carbon chain as the longest carbon chain, so we have only one substituent. So this is the only isopropyl group is the only one substituent. Right, if I select this longest carbon chain, then I end with 2 substituent. One is ethyl group, another one is methyl group. These are the 2 substituent. What rules says? So if there are more than one longest carbon chains, if there are one or more possible longest carbon chains in the given molecule, then which longest carbon chain I have to select? Then select the longest carbon chain which is having more number of substituents. Here we have 2 substituents. In this case we have only one substituent, isopropyl. Therefore we are not supposed to consider this as a longest carbon chain. Right, we are not supposed to consider this as a longest carbon, but this, if you consider this as a longest carbon chain, then what happens? We end with 2 substituent in this molecule. Right, so therefore this is the molecule. This is how we have to select the longest carbon chain. That is what the rule says. So now next rule is we have identified the longest carbon chain. That is the first rule. Second rule is we have to number the longest carbon chain. So if I start numbering from this carbon 1, 2, 3. So the second carbon bearing the substituent will get the least number, right? If I start from this carbon, so 1, 2, 3, 4, fourth carbon bearing the substituent will get the least number, that is the fourth number. Therefore this way of numbering is the correct way. Third one is I have to write the name according to the structure. First I have to write a prefix. There are more than one different substituent in the molecule, therefore list the substituent in the alphabetical order while writing the prefix. Therefore I have written ethyl, at the third position ethyl, at the second position methyl. We are not supposed to list the substituent in the prefix according to their position. 2 comes first, therefore I have to write 2 first. That is not correct, right? So even though ethyl group is getting third position, I have to write it first because it comes alphabetically first. So this is what the ninth rule is, sub rule is, right? So now let us move on to the next sub rule. For that we have to understand the meaning of complex substituents. The meaning of complex substituent. I am going to write those substituents here. Now, in order to understand the next sub rule, that is related with the complex substituents like this. So such type of complex substituents. So let us take this example. So I have written already this. So this is the molecule. We are understanding the meaning of complex substituents and how to write their prefix name of the substituents. So this is the molecule. So first rule is identify the longest carbon chain in this molecule. So let us start from this carbon. 1, 2, this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Right. Another way is, another longest carbon chain is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Right. So you can choose both the longest carbon chains, because this substituent is also having 5 carbons, this substituent is also having 5 carbon. Right. So therefore I am going to choose the straight chain as the longest carbon chain. Right. So second rule is number the longest carbon chain. So I start numbering from this carbon, because if I start from numbering from this carbon bearing the substituent will get highest number. So if I start numbering from this carbon, it will get the least number. So therefore 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. This is how I have numbered the longest carbon chain. Right. So next one is I have to write the name according to the structure. So this substituent is nothing but a 5 carbon containing substituent. Therefore the name of this substituent should be pentyl, right? This substituent is pentyl. This is at the 6th position. Therefore what I have, only one substituent in this molecule, therefore 6, name of this molecule is 6, at the 6th position. Pentyl group is there, pentyl. So this is the prefix. So root word is how many number of carbons? 20. So if there are 20 carbons in the longest carbon chain, then I have to use Icos as a root word. Remember this, up to 10 we have discussed, but if there are 20 carbons in the longest carbon chain, then we have to use Icos as a root word. So therefore pentyl, 6 pentyl is the prefix, Icos is a root word, 20 carbons in the longest carbon chain, and carbon to carbon single bonds, therefore ANE. Therefore the name of this molecule is 6-pentyl icosan. 6-pentyl icosan is the name of this molecule. So I am not going to write the longest carbon chain. So in this example, so I am just writing the 6th carbon to which the substituent is attached. Right. So it means that it is having 20 carbons in this longest carbon chain. Just remember like that. right? So it is a ICOS is the root word for this longest carbon chain. This is the longest carbon chain, right? So like that. At the 6th position, only substituent I have indicated because of the lack of the space here, right? So now, so let us take this molecule. In this molecule, I have just indicated the 6th carbon to which the substituent is attached, right? So I am not writing the entire 20 carbon longest carbon chain in this molecule. So you just remember here we have a 20 carbon longest carbon chain. So I just want to explain about the complex substituent, right? So what is the trivial name of this substituent? What is the trivial? So that we have discussed in the first video, right? First video of the Iupac nomenclature. What is the name of this substituent? What is the name of this substituent? So this is 5 carbon containing substituent. So therefore, and along with that there is a iso group in this molecule, iso CH3 CH3, such type of groups are there at the end of the chain. Then we have to call it as an iso group, right? So therefore the name of this substituent is isopentyl, right? What is that? Isopentyl. The name of this substituent is isopentyl. So now write this is isopentyl is the trivial name of this substituent. Remember that is not the systematic name of this substituent. So that is the trivial name of this substituent. This is the complex substituent now, right? So now I have to write the name of the molecule. So first I have to write the prefix. So how to write the prefix? So at the 6th position, isopentyl group is attached. Isopentyl. Then isopentyl. There are 20 carbons in the longest carbon chain. This is the prefix. 20 carbon, that is the root word. Therefore, icosan. Icos. Only carbon to carbon single bond. ANE is the name of this molecule. Right? Isopentyl icosan. So now let us take this example. So here also, this is also the same case. Longest carbon chain is not indicated here, but we have to imagine that there is a longest carbon chain in this molecule. So this substituent, this is the substituent, right? So this is whole thing is the substituent, right? We don't know the trivial name for this substituent. I have not given the trivial name for this substituent in the first part of the Iupac nomenclature video, right? So let us keep this molecule as it is. We will come to that later. So let us take this molecule. This molecule at the 6th position, substituent is attached. At the 6th position, this substituent is attached here, right? So now I have to, we know the trivial name for this substituent, 5 carbon containing substituent. So we know the trivial name for this. So what is the trivial name for this? Secondary pentyl, right? So secondary pentyl, because this is the carbon, this is the secondary carbon through which it is attached to the main chain. Therefore, this is the secondary pentyl. To which carbon it is attached to the main chain? So 6th carbon. At the 6th position, secondary pentyl is there. So just remember how I am writing this. Secondary is a small letter, P is a capital. That means P is the first letter of this substituent. S is not the first name. You have to remember that. Right. So 6th position, secondary pentyl group is there. So then what is the root word? Icos. ANE is the name of the primary suffix. So ANE is the primary suffix. So now let us move on to this molecule. So let us move on to this molecule. At the 6th position, this substituent is attached. What is the name of this substituent? The name of this substituent is nothing but neopentyl. That is the trivial name of this substituent, complex substituent. So therefore, at the 6th position, right, at the 6th position, neopentyl group is there, right? At the 6th position, neopentyl group is there. And what is the root word? Icos. ANE is the primary suffix. So what about this? This is another molecule. So here the substituent is this one, complex substituent is this one, right? So what is the name of this substituent? It is nothing but tertiary pentyl 5 carbon containing substituent with a tertiary carbon through which it is attached to the 6th position of the longest carbon chain. Therefore 6 TRT, tert, tertiary pentyl icosane. So here isopentyl is the trivial name of this substituent. So secondary pentyl is the trivial name of this substituent. Neopentyl is the name of this substituent. So tertiary pentyl is the name of this substituent, right? So here just observe, I have used iso, I as a capital, that means I is the first letter of this substituent. Secondary pentyl, P is capital, that means secondary sec is not the first letter, S is not the first letter of this substituent, name of this substituent. Neo, N is the first name of this first letter of this substituent, therefore I have written it in a capital letter. So tertiary is not the first letter of this substituent, P is the first letter of this substituent, right? So now let us move on to this molecule. We don't know how to write the trivial name of this substituent, so we have to go for the systematic naming, IUPAC naming for such type of complex substituent, right? So how to write a systematic name for this complex substituent? So first rule is, again you have to follow those 3 main rules. You have to identify the longest carbon chain starting from the carbon through which it is attached to the main chain, that is important. You have to identify the longest carbon chain in this substituent from the carbon through which it is attached to the main chain, right? Let us start with this carbon now, right? So carbon 1, 2, 3, 4. So this is the longest carbon chain. We are not supposed to consider this one, 1, 2, 3, 4. This is wrong. Why it is wrong? Because this carbon is not attached to the main carbon chain. Therefore identify the longest carbon chain in the substituent, complex substituent. From the carbon through which it is attached to the main chain, you have to select the longest carbon chain. From this carbon only you have to select the longest carbon chain in the substituent. So this is the straight chain, this chain is the longest carbon chain in this. So again number the longest carbon chain, 1, 2, 3, 4. How to number the longest carbon chain? From the carbon through which it is attached to the main chain, that carbon must get the number 1. You are not supposed to number this carbon as first carbon, 1, 2, 3, 4, that is wrong. From the point of attachment you have to number the longest carbon chain. So 1, 2, 3, 4 is the right, 1, 2, 3, 4, that is wrong, right? From the point of attachment you have to consider the longest carbon chain and you have to number the longest carbon chain of the complex substituent. Now that is over. Now write the name. How to write the name of this substituent, right? So I am going to write here at the second position. At the second position methyl group is there. At the second position, right, methyl group is there. At the second position methyl group is there, right? Next, that is the side chain of this substituent, 2-methyl. Next, how many carbons in the longest carbon chain? 4. Therefore bute. So bute, this whole thing is a substituent, therefore I have to use butyl. 2-methyl butyl. So this is the name of this substituent. This is the systematic name of this substituent. Remember this, right? So now at which position it is attached to the main carbon chain? To which carbon this substituent is attached to the main chain? So it is attached to the 6th carbon, right? At the 6th carbon, at the 6th position, this substituent is there, 2-methyl butyl. You have to write that whole complex systematic name of that whole complex substituent within the parenthesis, within the bracket you have to write. So now 6-2-methyl butyl, that is the name of systematic name of this substituent. Now prefix is over. Prefix is over. What is the root word? How many number of carbons in this longest carbon chain? 20. Therefore Iupac ANE is the root word. This is the name of this molecule. Then let us try to write the systematic name for these substituents for which we know trivial names also. So let us write the systematic name for this substituent. So what we have to do is, we have to identify the longest carbon chain from the point of attachment to the main chain in the complex substituent. This is the longest carbon chain, this is the longest carbon chain, or you can choose this also the longest carbon chain. Right. So now number the longest carbon chain. 1, 2, 3, 4 is the longest carbon chain. So now how to write the prefix name of the substituent for this complex substituent? At the third position, right? So methyl group is there, methyl. At the third position, methyl group is there. Then how many number of carbons? 4, butyl, 4, 3-methyl butyl. But is the number of carbons in the longest carbon chain, but YL is indicating that this whole thing is a substituent. So to which carbon it is attached? At the 6th position it is attached. Therefore we have to write this whole thing in the bracket. And next thing is Iupac AN is the name of this molecule. Systematic name of this substituent is 3-methyl butyl. So what is the name of entire molecule? Iupac 6. At the 6th position, 3-methyl butyl is the substituent, Iupac is the root word, and AN is the primary suffix. So we know how to write the systematic name for this substituent. We don't know the trivial name for this substituent. So now how to write the systematic name for this substituent now? So again 1, 2, 3, 4 is the longest carbon chain and numbering. We are not supposed to consider from this carbon because this carbon is not directly attached to the main chain. Therefore 1, 2, 3, 4, right? So 1-methyl at the first methyl, at the first carbon methyl group is attached, and butyl is the name of this substituent, systematic name of this substituent. To which carbon it is attached? At the 6th carbon it is attached. Within the parenthesis I have to write this. And Iupac AN is the root word and primary suffix. So now let us write the systematic name for this substituent. Longest carbon chain is 1, 2, 3. From the point of attachment you have to number the longest carbon chain 1, 2, 3. So at the second position, right, at the second position 1-methyl group is there. At the same second position one more methyl group is there, right? 2-2-dimethyl, 2 methyl groups. Therefore 2,2-dimethyl. So next thing is 3 carbons in the longest carbon chain. Therefore propyl, 2,2-dimethyl propyl is the name of this substituent. This is present at this is attached to the 6th carbon of the longest carbon chain, right? So next thing is root word Iupac ANE is the primary suffix. So this is the name of this molecule containing this complex substituent, right? So now let us understand how to write the systematic name for this substituent. So again longest carbon chain 1, 2, 3, right? At the first position 1-methyl group is there. Again at the first position again another 1-methyl group is there. So therefore dimethyl and 3 carbons, therefore propyl. So this is the name of the complex substituent, this complex substituent. So this is attached to the 6th carbon and whole name of the substituent is written within the bracket. So next thing is I have to write icos as a root word, ane is the primary suffix. Right. So what we have discussed in this case is pentyl, isopentyl, secondary pentyl, neopentyl and tertiary pentyl. These are all the trivial names of the substituent, complex substituent containing 5 carbons. Right. Right. And one more thing what we have discussed is how to write the systematic name. So how to write the systematic name for the substituents, such complex substituents. So that is what we have discussed. Right. We will understand in detail about such type of complex substituents by taking some more examples. So now let us take this example in order to understand the systematic and trivial name for the complex substituents. So this is the molecule. First rule is you have to identify the longest carbon chain. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Or 1, 2, 3, 4, 5, 6, 7, 8, 9. So there are two possibilities, straight chain or this chain. So if I take this chain, so you will get a 4 carbon bearing substituent. If I take the longest carbon chain, then I will get the same substituent at the same position. So therefore I am going to consider this straight chain as the longest carbon chain. And now you have to number the longest carbon chain. If I start numbering this longest carbon chain from this carbon 1, 2, 3, 4, 5th position. If I start from this carbon 1, 2, 3, 4, 5, 6, it will get the 6th number. This carbon will get the 6th number. Therefore, this way of numbering is the correct. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now we have to write the name of this molecule according to the structure. So what is the structure? First we have to write the prefix. Prefix is nothing but the name of the substituent. At the 5th position, butyl group is attached. So what is that? Butyl group is attached. At the 5th position, butyl group is attached. So this is the prefix. Root word is dec. 10 carbons, therefore dec. So next carbon to carbon single bond, therefore ane. So dec ane. 5-butyl decane is the name of that molecule. So now consider this a substituent. Consider this molecule. Again the substituent, this substituent is attached to the 5th position of the longest carbon chain. This is the longest carbon chain. Right. At the 5th position this substituent is attached. So now we know the trivial name for this substituent. So iso group is there. Iso group is there. Therefore the name of this is this substituent is isobutyl. Isobutyl. Right. To which carbon it is attached? At the 5th position. 5-isobutyl is the prefix. Then root word is dec. Ane is the primary suffix. So this is the name of this substituent, isobutyl. So what about this? The secondary carbon through which it is attached to the main chain. Therefore this is the secondary butyl. The trivial name for this substituent is secondary butyl. Secondary butyl, and this is attached to the 5th position. Therefore 5 secondary butyl. At the 5th position secondary butyl is attached. So root word is dec. Ane is the primary suffix. So what about this? At the 5th position this tertiary butyl is attached. This substituent is known as tertiary butyl. Right. So tert butyl, tertiary butyl. To which carbon it is attached? At the 5th position it is attached to the main chain. So the name of the root word is dec. Ane is the primary suffix. So here butyl, so isobutyl, secondary butyl and tertiary butyls are the trivial name of this type of complex substituent, right? So I can also write the systematic name for these substituents, systematic names. So let us start with this one. So first, if you want to write the systematic name for this substituent, you have to identify the longest carbon chain from the carbon through which it is attached to the main carbon chain. So this is 1, 2, 3 is the longest carbon chain, number 1, 2, 3. At the third position, methyl group is there, therefore 2-methyl, right? So how many number of carbons? 3 carbons, therefore proper. This whole thing is a substituent, therefore propyl. So to which carbon it is attached? At the fifth position it is attached to the main chain, carbon chain. This whole systematic name of the substituent is written within the bracket. Then root word is dec. Ane is the primary suffix. This is the systematic name of the substituent and the name of the molecule. So now let us write the systematic name for this substituent. Longest carbon chain is 1, 2, 3. From the carbon through which it is attached to the main chain, we have to consider the longest carbon chain from that carbon. So number should also be started from that carbon, 1, 2, 3. So at the first position, methyl group is there. So 3 carbons, prop. Whole thing is a substituent, therefore YL. So it is attached to the main carbon chain at the fifth position, 5. This whole substituent name is written within the parenthesis. So next thing is dec. Ane is the primary suffix. Dec is the root word, Ane is the primary suffix. This is the systematic name of this molecule. So how to write the systematic name of this substituent and the molecule? So longest carbon chain is 1, 2. So here many students may confuse that, so in this case 1, 2, 3 carbons are there. No. So what rule says is, while identifying the longest carbon chain in the substituent, so the carbon which is attached to the main chain, that should be the point of start for the identification of longest carbon chain. So you have to start identifying the longest carbon chain from the carbon that is attached to the main chain. So if you start here, this carbon is not attached to the main carbon chain. Therefore 1, 2, either you can choose this one or 1, 2, this one or 1, 2, all are identical. Right. So 1, 2 is the longest carbon chain. 1, 2 is the longest carbon chain. Numbering should start from the carbon, from the point of attachment to the main carbon chain. 1, 2 is the numbering. We are not supposed to number 1, 2. So now, what is the systematic name? At the first position, 1 methyl group. Again at the first position, 1 more methyl group. Therefore, dimethyl. So again 1, 2 is the longest carbon chain in the substituent, therefore ethyl, eth, right, whole thing is the substituent, therefore YL, ethyl, right. So next, so to which carbon it is attached? To the main chain, at the fifth carbon, whole thing is written within the bracket, and dec is the root word, Ane is the primary suffix. So here iso, secondary butyl, tertiary butyls are the trivial names of this 4 carbon bearing substituent, right. So these are the systematic name of those substituents, right. So in trivial names, iso, I is the first letter of this whole substituent. Secondary, S is not considered as a first letter of this substituent, name of the substituent. Tert is not, B is considered as the first letter, T is not considered as the first letter of this substituent. Now let us consider one more set of example. So this is the molecule. Identify the longest carbon chain. 1, 2, 3, 4, 5, 6, 7, 8. One longest carbon chain. 1, 2, 3, 4, 5, 6, 7. No. 1, 2, 3, 4, 5, 6, 7, 8. So either we have to choose straight chain or we have to choose the bent chain. So we can choose this chain 1 2 3 4 5 6 7 8 as the longest carbon chain, and the numbering should be done from this side only, because this will get the least number compared to either side of the numbering. So now what is the name of this molecule? How to write the prefix for this? At the fourth position, propyl group is attached, that is the prefix. Root word is oct. ANE is the primary suffix. 4-propyl octane is the name of this molecule. So now consider this one. So straight chain is the longest carbon chain. So therefore 1 2 3 4 5 6 7 8. So here this is the substituent, right? So in this case same 3 carbon containing substituent. So now 1 2 3 4 5 6 7 8. 1 2 3 4 5 6 7. So straight chain is the longest carbon chain, and numbering should be done like this only. And how to write the name of the molecule? So at the fourth position, at the fourth position, so what is the name of this substituent? That is nothing but isopropyl, right? So isopropyl. So how many number of carbons in the longest carbon chain? 8. Therefore oct, ANE is the primary suffix. This is the trivial name of this substituent. You can also write the systematic name for this. So identify the longest carbon chain in this. 1 2 is the longest carbon chain, right? At the first position methyl group is there. Then how many number of carbons in the longest carbon chain? 2. Therefore eth is indicating the 2 carbons in the longest carbon chain, and YL indicates this is the whole thing is the substituent, name of the substituent, 1-methyl ethyl. This whole substituent is attached to the fourth position in the longest carbon chain, and oct is the root word, ANE is the primary suffix. So this is the name of the molecule. This thing is the systematic name of the substituent. This one, isopropyl, is the trivial name of this substituent. So now let us move on to the next subrule. For that we have to take an examples. So this is the molecule. First thing is you have to identify the longest carbon chain. We have to identify the longest carbon chain in this molecule. So 1 2 3 4 5 6 7 8 9, right? So this is the longest carbon chain. Next rule is number the longest carbon chain. So if I start numbering from this carbon 1 2 3 4, fourth carbon will get the substituent. 1 2 3 4, fourth position again it will get a substituent, right? If the 2 substituents are present at the equivalent positions, then number the longest carbon chain in such that the least number should be given to the substituent which comes alphabetically first. Now for that list the substituents. What are the substituents which are present in this molecule? So I am just using the trivial name first for these complex substituents. After that we name it by using systematic name of these substituents, right? So this one is ethyl. At ethyl group is there. One is ethyl. Another one is tertiary butyl. Another one is, so this one is isopropyl, right? Isopropyl. These are the 3 substituents which are present in this molecule. So rule is there are 2 different substituents at the equivalent position, then number the longest carbon chain in such that least number should be given to the carbon bearing the substituent which comes alphabetically first. This one, both 2 substituents, ethyl group and another one is tertiary butyl group, which comes alphabetically first. So E is the first letter of ethyl group. So in this confusion start. Tertiary butyl, whether I have to take T as a first letter or B as a first letter. So for that the rule is subrule 10. What subrule says? While writing the trivial name of the complex substituent. Secondary and tertiary should not be considered in alphabetizing. Secondary and tertiary, S should not be considered as a first letter, and T should not be considered as the first letter in alphabetizing the substituents. So next thing is iso and neo should be considered in alphabetizing the complex substituent. This is what the rule is, right? So while writing the trivial name of the complex substituent, secondary and tertiary should not be considered in alphabetizing, and iso and neo should be considered in alphabetizing the complex substituent. Therefore, so tertiary butyl, so what is that? Tertiary butyl, another one is ethyl, another one is isopropyl. These are the three substituents. So tertiary, I am not supposed to consider T as a first letter, so I should consider I as a first letter. So for the simple substituent like ethyl group, E is the first letter, right? So therefore, how to number this molecule? So I am not supposed to start from this carbon, because this carbon is having ethyl group E. Compared to that, B is the first letter here, butyl B. This comes alphabetically first. Therefore 1 2 3 4 5 6 7 8 9. This is what my numbering should be. So now I have to write the name according to the structure, right? So first I have to write the prefix at the fourth position. Tertiary butyl is attached, right? At the fifth position, isopropyl group is attached. At the sixth position, ethyl group is attached, right? So I have to list the substituents in the alphabetical order while writing the prefix. So which comes alphabetically first out of E, B and I? So B comes first. Therefore 4 tertiary butyl. Then next one is EI. Out of these two, E comes first. At the sixth position, ethyl. At the fifth position, so isopropyl. So this is what the prefix is. What is the root word? So root word is 9 carbons, non-ANE is the primary suffix. This is the name of this molecule. So here I am using the trivial name of the substituent. So while writing trivial name of the complex substituents, secondary, tertiary should not be considered in alphabetizing. That you have to remember. Secondary and tertiary, T and S should not be considered as the first letter of the substituent. And iso and neo, I and N should be considered in alphabetizing the complex substituents along with the simple substituent. Right. So just observe this. I is coming next to the E in alphabetical order. Therefore, E ethyl is written first. T, actually it comes after E. Right. So, but I am writing this substituent first. Why it is so? Because we are not considering T as the first letter of this substituent. That is what the rule is. Right. So now let us try to write the systematic name of these substituents. So this is one substituent, this is another substituent, right? So what is the name of this substituent, systematic name of this substituent? I have to number the longest carbon chain 1, 2, right? So therefore name of this substituent is 1-methyl eth, 2 carbons eth ethyl. This is the name of this substituent. So what is the name of this substituent? Longest carbon chain 1, 2. So therefore 1, 1 at the first carbon 1 methyl group, first carbon 1 methyl group, therefore dimethyl 1, 1, 1, 1 dimethyl. Longest carbon chain is ethyl is one more substituent, systematic name for this substituent. What is the name of this? Ethyl. These are the three substituents, right? So now this is the longest carbon chain. So I have to number the longest carbon chain in such a way that least number should be given to the carbon bearing the substituent which comes alphabetical first if two different substituents are present in the equivalent position in the longest carbon chain. These two are present at the equivalent position. Therefore, how to number this according to these names? So E, D, M, which comes alphabetically first. So here M is the first letter of this substituent. So in this substituent, so which one I have to consider as a first letter? So in earlier class what I told is di, tri, tetra should not be considered in alphabetizing the name of the important point, name of the simple substituent. But this is not the simple substituent. This is the complex substituent. Therefore, what the next rule is? The next rule is di, tri, tetra, etc. should be considered in alphabetizing the complex substituents. While writing the systematic name, not a trivial name, systematic name. So, right. So I have to consider this D as a first letter. Di, tri, tetra should be considered in alphabetizing the complex substituents. So that is not true for the simple substituents. In some simple substituents, we have to ignore di, tri, tetra in alphabetizing the names. So if it is a dimethyl, then we have to ignore D. E has to be considered as a first letter. But that is not the case for this complex substituent. This complex substituent, dimethyl, D should be considered as a first letter. If it is a diethyl, so one more ethyl group is there, diethyl, then what we have to do? E should be considered because as a first letter. E should be considered as a first letter because this is the simple substituent. It is not a complex substituent. Therefore, D is the first letter of this substituent. So next one is E is the first letter of this substituent. So M, D, E, out of these three, which comes alphabetically first? D comes alphabetically first. Therefore, I have to write this substituent first. 1, 1 dimethyl, ethyl. I have to write this within the bracket. To which carbon it is attached? Fourth position. At the fourth position, 1, 1 dimethyl ethyl. Next one is Me. Out of these two, which comes alphabetically first? Ethyl. At the sixth position, ethyl group is there. Right. So next one is fifth position. At the fifth position, so within the bracket, 1 methyl ethyl. This is the prefix. Now I have to write the root word. So 9 non ane is the primary suffix. This is the systematic name of this molecule. So one more rule what we have understood here is, so while writing the systematic name for complex substituents. Di, tri, tetra, etc. should be considered in alphabetizing. Should be considered in alphabetizing. This is the rule. That is why I have written D. D is the first letter of out of these three substituent. M, E, D. Out of these three, D comes first. So why I have to consider this D as a first letter? Because this is the complex substituent. Systematic name of complex substituent. Therefore, D should be considered. Right. So E, even if there is a diethyl, one more ethyl group is, suppose one more ethyl group is there at the 6th position, then I have to write diethyl, then we should not consider that D as a first letter. Why it is so? Because that is the simple substituent. It is not a complex substituent. While writing the complex substituent only, we have to treat di, tri, tetra in alphabetizing the substituent names. So let us take one more example to understand this rule. This is the example. So identify the longest carbon chain. 1, 2, 3, 4, 5, 6, 7, 8, 9. Right. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Therefore, this is the longest carbon chain. Right. So number the longest carbon chain. 1, 2, 3, 4, 5. Right. 1, 2, 3, 4, 5. Fifth position is having the substituent. So again 1, 2, 3, 4, fourth position. Therefore 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This is the numbering. Now what are the different substituents? So at the fourth position, ethyl group is there. Right, at the fourth position ethyl group, and at the sixth position, so what is the name of this substituent? So neopentyl, name of this substituent is neopentyl. Right, whole group is neopentyl. This is the trivial name of the complex substituent. So out of these two, remember, while writing the trivial name of the complex substituents, iso and neo should be considered in alphabetizing. So therefore E comes first compared to N. Therefore 4 ethyl, 6 neopentyl. So dec is the root word, ane is the primary suffix. So this is the name of this molecule. So now let us use the trivial, systematic name of this substituent. So systematic name for this is 1, 2, 3 is the numbering and longest carbon chain. So at the second position, again at the second position, so dimethyl, 2 methyl groups at the second position, and again at the second position dimethyl. Right. So then longest carbon chain 3 prop YL, because it is a substituent. This is the systematic naming of this substituent. So now this is one substituent, this is another substituent. So in this substituent E is a first letter. So in this case, according to the rule, while writing the systematic name of the complex substituent, di, tri, tetra, etc. should be considered in alphabetization. Right. Therefore D is the first letter of this substituent. So therefore ED, which comes first? D comes first. Therefore I have to write 2,2-dimethyl propyl. So this is the name of this substituent, systematic name of this substituent. To which carbon it is attached? At the 6th carbon it is attached. Right. So next thing is 2,2-dimethyl propyl. Then next substituent is at the fourth position ethyl. Next root word is dec. Primary suffix is ane. This is the name of the molecule. Either you can name this one or this one. Both are correct according to the IUPAC rules. So in this class we have discussed only two rules. First rule is, if there are two possible longest carbon chains, then we have to choose the longest carbon chain which is having more number of substituents. That is the first rule what we have discussed. Second rule is, while writing the trivial name of the complex substituents, trivial name, so secondary, tertiary should not be considered in alphabetizing. Iso and neo along with that cyclo should be considered in alphabetizing. These two are for writing trivial name. So this one, while writing the systematic name of the complex substituent, di, tri, tetra should be considered in alphabetizing. So this is for complex substituent. So thanks for watching the video, and please share the video with the students in need. Thank you so much.